How does a soldering iron work, and what are its key parts? Imagine connecting tiny electronic parts with a tool that melts metal like magic. That's what a soldering iron does, and understanding how it works can boost your practical skills in electrical projects. A soldering iron is a hand tool used by electrical engineers and technicians to join metal parts, especially in electronics, by melting a filler metal called solder. The process creates both electrical and mechanical connections between components, such as wires, circuit boards, and electronic parts. The core of how a soldering iron works is resistive heating. When you turn it on, electric current flows through a heating element inside the iron. This element is made of a high-resistance alloy like nichrome, which heats up as current passes through it. The heat then transfers to the metal tip of the iron, which is designed to conduct heat efficiently. When the tip gets hot enough, it melts the solder placed on the joint. The molten solder flows into the gap between the parts, and when it cools, it forms a strong bond. Now let's look at the main parts of a soldering iron. First is the heating element, which is usually made of nichrome wire. It converts electrical energy into heat and determines how hot the iron gets. Next is the tip or bit, which touches the workpieces. Tips are often made of copper because it conducts heat well and are plated with iron or other metals to resist corrosion. Tips come in different shapes and sizes, like pointed or chisel, for various tasks. The handle is insulated to protect you from heat and electric shock. It gives you control and comfort during soldering. The power cord supplies electricity from the wall outlet to the heating element. Some soldering irons are cordless and use batteries or gas instead. Advanced models include temperature controls, which let you set and maintain a specific tip temperature. This helps prevent overheating sensitive components and makes your work more precise. There are different types of soldering irons. Basic direct heat models have a fixed temperature, suitable for simple jobs. Constant temperature irons keep a steady heat, perfect for electronics. Induction soldering irons use electromagnetic induction to heat the tip quickly and are more durable, often used by professionals. In electrical engineering, mastering soldering techniques is key. Proper use involves heating both the component lead and the pad or wire, then applying solder so it flows smoothly and forms a shiny, concave fillet. Using flux, which is often in the solder wire, helps clean the metal surfaces and improves bonding. Different tips and temperature settings are useful for specialized tasks like surface mount technology work, where tiny components need careful handling. Safety is important. Always work in a well-ventilated area to avoid fumes from flux and solder. Regularly clean and tin the tip to keep it in good condition and prevent oxidation. Store the soldering iron properly to extend its lifespan. In summary, a soldering iron works by converting electrical energy into heat through a resistive element, transferring that heat to a metal tip, and melting solder to join metal parts. Its main parts are the heating element, tip, handle, and power source, with some models offering temperature controls. Learning how to use it correctly is essential for building reliable electronic devices and fixing circuits.